on like
Or
the
like
day.
secret word.
Yeah.
I would just skip forward until I like find
No,
the
I
secret
saw
word.
one like that.
Did you have a bracket or something?
Okay, so what types of variation have we seen so far?
It happened
Carlo?
fast. Yes.
What types of variation have we seen so far?
We've seen like combined variation, we've seen inverse variation, we've seen direct variation. I think one more, but I don't know what it is.
Joint variation.
Inverse.
Like I said.
Wait, can you write the like formulas for all of them?
I'm gonna have you do it.
Well, like, can you put them
And
on
then
board?
what am I missing? Inverse?
Joint. Joint.
Mar-
Inverse combined.
Oh,
Carlo.
Direct.
Carl and Kira, class has started.
Direct.
Sorry, sir.
Direct.
Direct.
Yeah. Yay.
Okay, so what are the formulas for that?
Direct is y equals kx, and then inverse is y.
Okay, I'm gonna put a column here for n equals 1.
Okay. Yeah. And then inverse is y.
What if n is not equal to 1 for direct?
Then it's y equals kx to the n.
Yeah.
Okay, and then go ahead, Amelia.
Y and then inverse is y equals k over x.
And
And y equals k over x to the n. Or k, with k, wait, no, k over.
you said it right. I just
Okay.
didn't write it right.
Okay. Yeah.
Wait, the y equals
And then combined is I don't know, but
Help us out, Warren.
What? Oh, combine y equals to kx over x.
No. So here, and when we only have two variables, I'm using y as my function. It's like y. It's like saying y is a function of x equals kx. Down here on combined, I need two independent variables. So I could say z here. I could say y equals x1 and x2, but let's just do x, y, and z. So where does the y go?
under.
Yeah, under. So combined means it's a combination of direct and inverse. Okay, so that's n equals 1. How do I generalize combined to other powers?
z
Yeah.
equals
Mm-hmm.
kx to the n
Yeah.
over y.
Okay, but that's not general enough.
Oh.
So far, so good.
I don't know.
Help us out, Kara.
Do you have to do y to the end too?
I do want to use a power, but I should not restrict it to be the same power. So let's say y to the m,
Okay.
because this is like n equals 1, m equals 1. So this would be first power here, first power here. That's just a special case of the more general case of when the variables can have exponents. So what's joint?
So when joint is y. Z equals x to the n, and also
So k always comes first.
oh yeah, k to the y, or what ky kx to the n.
That's over here. I'm going to use powers over here.
Okay, and then y.
Yeah. So the idea for
Is
joint.
multiplying each one.
So joint means it's jointly direct variation. So it's proportional as x and y. So combined means I have something that's direct and something that's inverse. These are both direct.
Wait, I have a crazy idea. You should do each like a very simple basic equation with like direct, inverse, combined, joint in that order.
Like an example.
Yes.
We're about to do an example for a joint,
I disagree
but then I
with all
also.
of them.
So how do I generalize this?
Z. Sorry, you can go. Sorry. I just been cooking all class periods.
Oh wait, Eric. Go, Eric.
Yeah.
Help us out.
Z.
Got that part.
Px.
Kx What?
I don't know what's next.
So what are we doing? What's the difference between this column and this column? Eric,
I see it. See the
Eric, what's the difference between the two columns?
N, up and
What?
yeah, N there.
They both have n. N is general case here. What is n here?
PX, Y, N.
What is n? What is n in this case? What is the implied exponent that I don't necessarily have to write? What's the exponent on x?
You're
Oh,
asking
N,
now?
N.
No, it's 1.
Oh.
Warren, what's the exponent on x?
1.
Right, if I don't write an exponent, that means it's implied. Amelia, I have to let other people answer too.
Sorry, I was.
You were right.
Yeah, I know.
So do you see that this is the general case is n, and like there's a special case where n equals 1?
Yeah.
Okay, so we're doing the same thing here. So this is in general. This is the formula for general variation, or variation in general. This is the formula for inverse variation in general, meaning for any exponent, or this would be just when the exponent is 1. This is the general case for combined. And now we're trying to make a general case for joint variation. Here's joint variation when the exponents are 1. Now I need to write it in a general sense for other exponents.
So it's N and M.
How do I write it?
X and up and
Z equals,
Z equal to K, X up and Y up and
we say x to the nth power, or x to the n,
X to the
and
Y to the M.
y to the m. Right. So if I have, so if I say use
Wait, can you just do one simple thing with all of them?
Joint.
In order.
variation to fill the table when k equals 3, and I say make a table here with x values, and let's see, it's a joint variation, so I'm going to say x here, y here, and z here.
Wait, will it tell us when like n does not equal 1? Or will there just be a power on it?
So the problems that we've been seeing so far say that volume is proportional to temperature, directly proportional to temperature, and inversely proportional to pressure with some constant. Or we'll say distance is proportional to the square of the time. So if it mentions a power, then you'll use n other than equals 1.
Okay.
So is this answering what you were wanting to see? Is like formulas with like example formulas?
Yeah, but
So here's combined. But what?
it's fine. Nothing.
I'm gonna change my example. So if my input is x and I say 0, 1, 2, 3, 4, what's my y if I'm using direct variation? I'm gonna make a table. What's my y?
Also 0, 1, 2.
0, 3, 6, 9, 12.
what's my formula for y?
Oh, y equals kx.
Kx. And we know that k is 3. So if I want to, I could write it as y equals 3x. So, say it again, Carlo.
0, 3, 6, 9, 12. Blaze.
Wait, how did you get the number? You just multiply.
What's my formula for y? Wait, Kira, what's my formula for y?
Y equals k over x.
I'm gonna fill in my k.
10 over x.
10 over x.
Did you guys say
So, Annabelle, help me fill out my table.
Harmonizing. So y equals kx, right?
No.
Or I mean, oh wait, y equals 10 divided by x.
Yeah, I'm using inverse variation when k is equal to 10.
Wait, can you show the work behind 10 if y equals 10 over x?
it's just y equals k over x is your inverse
When you
variation,
plug
and
in
you just
k.
plug in k.
I see.
So go, Annabelle, give me the first one.
-5
No.
or 10 over 10.
Oh, you -5. Oh, I'm so sorry.
-5.
I'm so sorry.
And
You are
then-
correct. All right, no wait, Sydney, go.
Wait, where? 10. No. -10.
There you go.
You didn't put a negative
Wait,
sign.
I was trying to go. -2, -1, 1, 0, 1, 2, 3. Charlotte, trick question.
Wait, I'm sorry.
So put the 0 and something.
Amelia, help her out.
-15.
No. Kira, go.
It's undefined because
Undefined.
0 can't be in the denominator.
Right, because this would be
Yes.
10 over 0, which is undefined. Charlotte, what's the next one?
10.
10, and then Amelia.
5.
Yep, and then Eric.
10 over 3.
10 over 3. Good job. You know everything about variation.
Now do it for the rest.
You like it, don't you, Carlo?
So the table part. You want to do the table? I can. Yeah. So,
I could get down.
all right. You pick. You want combined or joint?
Combined.
Okay. So use
Wait, we used to use direct.
combined variation to fill the table when k equals 2. Now I'm going to have to think about what I want to do here. So x, y, and z. Let's just do -2, -1, 0, 1, 2, -2, -1, 0, 1, 2. And what's my formula for z? Let's see. Warren,
Yeah.
what's my formula for z?
Z equals to kx over.
I know what k is.
So that's 2x over
2x over y. How did you get that?
That?
because k is 2.
K is 2, so we know that we put that in for k. And how else did you get it? Where did you get the basic formula?
From there.
From combined?
Yeah.
Right. Okay, Carlo, can you help us out?
With Z?
The z, what's the first value of z?
It'd be 2.
2 because it's 2 times minus 2 over minus 2. Kira?
Also 2?
It's also 2. And Annabelle?
It's gonna be 2. And then it's gonna be 2 again.
No.
Or, no, sorry, it's undefined.
Undefined. Because it's 2 times 0 over 0. And then Sydney?
2 times 1. Wait, what is y equal?
1.
Oh, so it'd just be 2.
And then Charlotte?
2.
Yeah, it's harder to set up a table for a three-dimensional formula, or a joint, or a combined or a joint. So really, I should have 2 minus 2 minus 1. Oops. 2 minus 1, 2, 0, 2, 1, 2, 2, and then also have maybe minuses here. And then minus 1 all the way across.
Wait, wouldn't 2 be 4?
Wouldn't 2 be 4?
Yeah, like the last number. Like when you plug in 2 for x? No. but-
Here?
Yeah.
So it's 2 times 2 divided by 2. 2 times 2 divided by 2. So unless it's undefined, these were just 2 all the way across. And then 0, 1, 2, and then 0, 0. There's zeros all the way across. Huh?
Are you just doing different variations?
I'm doing different variations because x doesn't have to equal y to get a meaningful table. So I kind of need a 3D table here. We don't have to fill it out, but I'm just kind of showing you the complexity of using 2 independent variables. No, not that either. So for each table, y goes from minus 2 to 2 all the way down, and then the x's go from minus 2 to 2. And so that would give you all the values from x going from minus 2 to 2 and y going from minus 2 to 2. If we filled out this entire table, then we would get a better picture for what z looks like. Annabelle?
Would we have to do something like this on quiz?
So not for combined or joint. But I wanted to show you.
So the quiz is really just focusing on derivative variation and inverse variation.
As far as tables go.
Oh.